Yeah. Hello everyone. I would like to welcome you all for today's session. Today our students have come up with learning series of workshops called Hack the Mountain Qubits. Qubits is a computing term. Another term for qubits is quantum bits. Just like small quantum of packets of information makes the whole information, in that way these series of workshops would help you become a tech geek at the end. So these workshops have already started from 20th September 2020 and they will go on till 9th of October 2020. These workshops will be conducted by industry professionals. Even if you're a beginner in the tech field, do not worry, these sessions will take you from the scratch. So, a question might be coming to your mind like, what would you get by attending these workshops? Learning and experience sharing by industry professionals, rewards for participants during the workshop, e-certificates to all the participants, and obviously a lot of networking with professionals. So stay tuned till the end of the video so that you can get the feedback link, and by filling the feedback link you can get the certificates. So coming on to today's session, ever heard about smart contract? A smart contract is a computer program or a transaction protocol which is intended to automatically execute, control, or document legally relevant events and actions according to the terms of a contract or an agreement. The objectives of smart contracts are the reduction of need and trusted intermediators, arbitrations, and enforcement costs, fraud losses, as well as the reduction of malicious and accidental expectations. So, we at Hags and Mountains have come up with this workshop on smart contract. So, welcoming you all, today's speaker, Punit Agarwal. He's the founder at Zubi.io. Zubi.io is designed to provide an experience platform that empowers millions of students towards emerging technologies. He has been involved in blockchain for more than 2.5 years now. Where his keen interest lies in research and protocol development, he was part of the student startup exchange program, a team of delegates that visited Silicon Valley to understand the global startup ecosystem and implement the same in India. So, with this, I would like to hand over the session to Puneet and all the rest.
Thanks, Niti, for a warm welcome. So, hello, guys. Thanks for all of those who are watching us currently. With the introduction to smart contract by Smriti, you might be in a notion that smart contracts, what exactly this is. So, it's not that complicated. Let's make it very easy today. So, let me just share the brief outline of what we'll be discussing on today. So, we'll be starting from what exactly is blockchain, what makes blockchain different from other databases, what makes it unique, what is the extra feature that blockchain comes up with, right? Next would be understanding about what exactly smart contracts are in a very layman term. Post then we'll write our smart contract. We'll learn about the basic building steps or the basic baby steps that are needed to write your own smart contracts. And then we'll deploy it on an actual blockchain network. Right. So without wasting in much of a time, let's start with this session with a quick introduction. So, as Smriti said, yes, I'm Punit Agarwal, the founder at Zubi. I have been working on blockchain for around 3 years now, and have built a lot of decentralized applications, also called dApps. I've written several smart contracts, worked on the protocol level of Ethereum, wherein we actually redesigned a new consensus mechanism, and we implemented that for a different company. So it was making the changes on the protocol level or the network level of Ethereum, and have been working in this space. So since I've been working, so I also pitched in a proof of concept as part of a student startup exchange program to the government of Rajasthan, through which I was selected and sent to Silicon Valley for around 15 days on a fully sponsored trip. So therein, we were exposed to multiple institutions, organizations, wherein I was part of a lot of emerging technology talks. I had been to UC Berkeley, Stanford, Google, Facebook, Apple, Intel, etc., and had actually learned about how these emerging technologies, shape up the future of tomorrow. Apart from this, on my academic and experience, I have also published a couple of research papers in the field of blockchain and healthcare. And currently, I'm working at Zubi to disrupt the lives of students and help them towards making their careers in emerging technologies. So, emerging technologies like artificial intelligence, blockchain, machine learning, quantum computing. I like the idea of qubits, which the anchor or which the host just mentioned about, right? We also have some areas of Internet of Things and cybersecurity for you to actually learn and gauge about these technologies and find a relevant career in it. So, starting with the blockchain, so let's understand what blockchain is. I would like to hear out from you on the comment section. So, what do you think is blockchain? I'll be taking in a pause here. I'd like to see your comments there. So, what do you think is blockchain is? Okay, I don't see any comments so far. Okay, Rakshat. So, do you want me to wait? No worries. We can just take things ahead now. So, blockchain is basically an immutable distributed ledger, right? So, it's like here. These are three different words. So, what ledger is? Ledger is nothing but a bookkeeping, wherein you actually have, a set of records, and you tend to keep that records, and that is a series of transactions. That is to and from transactions. You can relate what ledger is with your Paytm passbook, right? In your Paytm passbook, you have to and from transactions, and like it's a list of transactions that have been deducted from your wallet and the transactions that have increased money at your wallet. So that basically is what ledger is. What distributed is, so distributed exactly means your data is being there with multiple people at same time. You can relate it with Google Slides. So you can actually share and add collaborators to Google Slides, and all of them can actually like edit, view, and comment on the Google Slides at the same time. So you'd be, the same set of data is with everyone. If the data is being changed, it's being changed with everyone that can access that Google Slides. So that is what means distributed. And immutable is something that cannot be changed. So if I say immutable, it means something which is there for forever. You cannot change that, and so that basically what immutable is. So if we just combine these three things, so blockchain is nothing but a data or a series of data, which is ledger, which is distributed among all the nodes in the network or all the participants of the network, and this data is shared in a way that these data cannot be tampered. That makes it unique, right? This is what blockchain is: immutable distributed ledger. It's nothing like a rocket science. It's no a fancy term or a hard a hard term for you to understand. It's basically three things: immutable distributed ledger. So coming next to smart contracts. So smart contracts is nothing but a contract that is built into code. What does that mean? So we all do see contracts in our daily lives. These contracts can be the physical contracts, the legal contracts that we see. And if you actually think more about it, so all of these contracts are nothing but if and then conditions. If this is met, then this has to happen. For example, let's say there is a contract between two people for an insurance claim, an insurance company and a person. If these diseases, if you come with these diseases, then insurance is passed. If this disease, then insurance is not passed. Right? You can actually relate to any contract into an if and then condition. So basically, smart contracts are the same, wherein they are the if and then conditions which are written, right? And coming next, so it's basically a business contract in a form of a program which resides on the blockchain network. So the network provides the computation required to execute the program. So basically, there's a code which stays on blockchain, and blockchain is the thing that defines on how a contract should run. So let's say if there's a contract between you and someone, right? In a physical world, if they breach, you have to go take in legal actions. You might have to, contact the judicial system of the country that you live in, and you have to get that checked out. But in this case, there's no scope of tampering that, because code is the law. And as every one of us know, whatever is written in the code, things will function around that. It won't be partial for you or me. It will entirely work same as the code and same as things that are being written on it. To execute the function of the program, permissions are provided to designated actors which verifies things, right? So let's say if a contract says, so it's same as the physical contract. So if a contract is being made by two parties, the two signatures are the ones who actually verify that. So let's understand in deeper about what exactly smart contracts are. So smart contract language, is a programming language that is either used to write smart contracts or is compiled to it. So smart contract languages for Ethereum are of like various types. Some of them listed here are Solidity, E-Worms, right, Viper, Ethereum bytecode. There can be these languages through which how you can write smart contracts on an Ethereum. So Solidity is the most popular smart contract language for Ethereum. So now we have chosen our language for the smart contract development. So in this workshop, we'd actually use Solidity to write our contract. Right? Solidity is one of the language which has been created by the Ethereum organization itself, and we'll be using the same Solidity language to write the smart contracts. So there are a plethora of choices available which overwhelm anyone on building a smart contract. Simplifying the environment setup is the first step towards delving deeper into the blockchain world. In order to set up the environment for developing a smart contract, there are two choices which are available. One is you can use Remix Online ID, or you can go with the local setup. So Remix is basically the first choice to use online Remix ID and to build and test the smart contracts. This is quick, easy, and recommended way for the beginners, right? So in this workshop, we'll be using Remix, but however, I'll just walk you through about if you have to use a local setup, what are the steps to do that, and what are the advantages and disadvantages of using a Remix versus using a local setup. So for the local setup, like there are various ways again. So one of them can be through Visual Studio Code, another can be through Node.js, there can be Truffle Suite, or there can be a Ganache. So I believe you might know how to install anything from Node.js. So basically, there are npm packages, and just you have to install by putting in the command like npm I and then the package name. So we'll discuss about the different things here, like Truffle and Ganache. So for Truffle, you can basically use that from npm install -g truffle. So this is the command that you can use, and through this you'll be getting the truffle installed on your system, right? And the other way to do that is Ganache. So through Ganache, you can actually download the Ganache client from this particular link, and you can use that. So there are different use cases of using it. From Truffle, it actually makes testing of smart contracts very easier when you're building in decentralized applications. Through Ganache, you can actually test multiple accounts. You can actually test in payments from one account to another in a very better way. So the pros and cons of using a system like this, right? So let's understand what are the pros of using a remix id. So for remix id, the pros are like you don't have to install anything. So there's no installation that is being required. It's completely online. You can get started without any challenges, and it's quick for prototyping and validating a smart contract. And it provides a local Ethereum virtual network. What are the cons of using it? So as the progression goes from smart contract to consuming the smart contracts in decentralized application, Remix has limitations. Yes. So if you're just writing the smart contract and testing it, then Remix is the platform to use. But if you want to integrate that smart contract and test it from a decentralized application, like let's say you're creating in an entire application and you want to test things out, Remix would actually limit a lot of options for you. So for you, the better approach would be for a local setup. So what are the pros here? It actually gives you flexibility in building up enterprise grade applications, and it makes it easy to build decentralized applications or dApps. What are the cons? So basically, setting up the environment is actually time taking, and it's a one time effort and it might take almost a day of yours to set up and to get familiar with things. So now, once we have understood about the pros and cons, so let's understand about the next things. So now let's get started with building our first smart contract. Right? So a smart contract, in essence, is a contract built into the code. For example, like let's consider an example here of a purchase order. So a purchase order is a contract that exists between a buyer and a seller, keeping it in the simplest form. Right? Create a very basic smart contract today, wherein we are just creating in a purchase order, and through that order, certain conditions have to be fulfilled for the purchase order to execute successfully. So few of the conditions are like a successful payment for the goods by the buyer, goods provided in the right condition to the buyer by the supplier, right? Goods delivered before the due date agreed upon the time of purchase, and the conditions for return of the goods agreed upon in the purchase order, right? So these are the four functions. So these are the four functionalities that we want from our smart contracts. So it basically gives you a successful payment for the goods for the buy, that has been purchased by a buyer. The goods provided are given in the right conditions. The goods are delivered before the pay date, and the payment has to be released at the time of purchase. And the conditions for the goods agreed upon. So let's say if you're ordering for a particular thing, so you have to get that thing. So these are some of the things that we need to take care of. So Solidity smart contract in essence is basically a collection of the following things. One is the data and the function. So what data here is? Data is something that maintains the current state of contract. Like it can be your integers, boolean, string, etc. And the function is which apply the logic to the transition the state of the contract. It's the same as the functions that we used in our native programming language. So your function is executes when a certain set of things are happening, and then you get out of the function, etc. So the pragma keyword can be used to enable certain compiler features or checks. You can see on the screen I've written about pragma directive, pragma solidity greater than equal to 0.4.0, less than equals to 0.6.0. So what does this mean? So this statement actually defines the source file, and it will not compile for the versions earlier than 4 and later than 6. So only the versions before 4 and 6 would be compiled successfully. So why do we do that? We do this to ensure that no unintended behavior is introduced when a new smart contract or when a new compiler version is being introduced, right? So it actually behaves in a way which has been expected. So when a new version is created, there might be some changes to the syntax, and that can actually throw in some warnings or errors to the contract. Hence we define it that this is the version which for which we are writing in the smart contracts. So the contract so in order to declare a contract, you use the keyword called contract, right? So the keyword contract declares an empty contract which is identified by the name of purchase order, because we have named the contract as purchase order in Solidity. So if we talk about the variables, variables are majorly of two types. One is the value type, second is a reference type. So value type are the variables, that are passed by value. Like they are always copied when they are used as function arguments or in assignments. For example, it can be integers, booleans, address, etc. And coming to the reference types, these are the types of variables which are actually complex and are passed by reference. So these variables do not fit into the 256 bit, and it has to be managed carefully as copying them is expensive, right? So you need to take care when you're using the reference type and the value type. So let's understand about how can we actually add data to smart contracts. So adding data to smart contracts, so like it's basically in the format of uint 256, where u means for unsigned integer. It means that, or u means unsigned, right? It means that this type can only represent positive integers, not positive and negative integers. It's very clear from the statement. I is in u int 256. So int here is the integer. 256 is 256 bit in size. So here the maximum value can be 2 to the power of 256 minus 1, and the minimum value can be assigned as 0. Right? So let's add some data variables to the contract. For every purchase order, there has to be some quantity or product associated to it. So let us add a variable product underscore quantity. This is what I've named it, which will be of a data type integer or number. So the variable we are introducing now is an unsigned integer and is represented by uint 256. The product quantity is only a positive value, and current assumption is that we are going to cater to a very large value for product quantity. So the product quantity variable is declared in the part of a contract state and hence is persisted or stored in the contract space. So currently, like the default value that it will set is, it will set the product quantity as 0, right? So default quantity is 0. We are assuming that the product quantity can go up to a very large number. Hence, we have used this number. We have used the data type called uint 256. Right? Is there any questions so far? Should you have any questions, feel free to drop them in the comment section, and like we can take things from there then. So coming next, so understanding the smart contract, understanding the constructors here. So constructor is called when contractor is deployed, right? So it actually initializes the contract with some value. So in the current scenario, the product quantity is set to 100. As you can see, I've set product quantity, as 100. So when the contract is deployed, this number would be set. So a parameterized constructor can also be created by passing a variable and initializing product quantity using the pass-in value. So what we are doing here is we are actually writing this number 100 inside, inside. We are directly giving the product quantity as 100. We can also, another way of doing that is we just take in 100 in some parameter and we pass that as a reference. We pass that as, like we pass that as a value and we refer that. So the key point to be noted here is the access modifier, which is the public, right? So the public keyword specifies that anyone can access this function. This is not a restricted function. Okay. So when we are adding functions, let's start adding some functions. So the format to add the function is function space, the name of the function, space, the access modifier, space, the state mutator space return value, right? So let's now add in a function to make our program interactive. Functions are controlled capabilities which can be added to a program. Any function is preceded by the keyword function. Overall, this is how the function declaration looks like. Function, and then the function name, access modifier, state mutator, return value. So let's write a getter function. So one of the most common requirements for any of the program is to read the stored value. In the following contract, we are going to need to read the product quantity value. In order to provide this capability, a read function or a get function is added. Right? In this function, we are not doing any manipulation to the stored value. We are just retrieving the stored value. Right? It's just getting the stored value. We are not writing any data there. So whatever the value of product quantity variable value, it simply would return that. This is how we write the getter functions in Solidity. So the name of the function is get underscore quantity, right? The access modifier is public here. The state mutator is view. This is what defines the getter, right? And it returns uint 256 because it returns like the product quantity which is of a type uint 256. So let's understand about the setter function. So reading the data is necessary and we have accomplished it in the last section. But most of the scenario also requires the capability to write or update the data as well. Is provided by adding a setter function. This function takes a value from the user in the form of an input parameter. Using the value provided to the function by the user to the variable to the value of variable, product quantity is written to update it. So let's say if we write in the setter function about product quantity is equals to product quantity plus value. So what we are doing here, we are actually setting what we are doing, we are setting the product quantity and we are updating it. And what is this keyword called value? This is something that we are passing in as a reference. So if you see here, so it's like function update underscore quantity uint 256 value, right? So we are passing to this function a variable called value, and whatever the number we are passing it with, product quantity would be added with that particular number. So let's say if the product quantity now is 100 and if we have added the value and let's say the value is 10, so what will this function do? This function would, take in the product quantity value of 100, add a value of 10, it becomes 110, and then it updates product underscore quantity with 110. Right? So this is how we add the setter functions in smart contracts. So let's just dive into the remix side. So like if we totally see our smart contract, so we have written about the pragma solidity. We have then written a contract of purchase order. We have then defined in a variable called or a data type of uint 256 and the variable is product quantity. We also call it as a state variable, right? We initialize it with a constructor. We have named the constructor, we have put the scope as public, and this constructor is setting the value of product quantity as 100. Then we just put in a getter function and a setter function, right? So far, is it clear? Do you have any doubts so far? Because now we have done writing our basic smart contract, right? Wherein we have firstly defined the version of it, then we have initialized the contract, and we have put in two basic functions, getter and setter, and one constructor to it, right? So I assume there are no doubts. So let's just move to the remix. So I've used the same function here. I'll just update this with the product quantity. So this is our Solidity contract. What I'll do, I'll just delete the existing deployed contracts, right? And then I'll just suspend this out. Great, yeah. So this is how our contract looks. So what I've done, I'll just start things from fresh. So we need to go to this website called remix.ethereum.org. Right. Just a second. Choose light. Yeah. So what I'll do, I'll just go here. I'll create a new file. Let's say I call it as what was the name of the constructor? Purchase order. So my contract name is purchase order. So I'll put the file name as the same. Purchase order dot sol. Dot sol is actually meant for dot solidity file. I put the same function here. Alright. Once I do that, there is this particular option which is called a solidity compiler. As you can see, so we have the version of 0. Greater than zero point 0.4, less than zero point 0.6. So what I need to do, I just need to change the version here. I need to go to 0.6.0. Alright. So I can choose anything from 0.4.0 to 0.6.0. So I've just chosen 0.6.0. The language is Solidity. The compiler version is default, right? And then I just compile this. So as you can see, the compilation is being done. And you can see two things here, ABI and bytecode. So ABI is basically application binary interface, which you would be needing when you're developing in decentralized applications. At certain stages, there you would need to copy your ABI, and bytecode is nothing but the machine level language that the Ethereum virtual machine would understand. So it's like, you write your program in C C++, and then you the machine makes that into a binary language. So similarly, above just the binary language, there's a machine level language. So bytecode here is the machine language, right? So I can see that my compilation is successful. I'll just come in next in order to deploy and run these transactions. So as I can see, there are like various environments here: JavaScript VM, injected Web3, and Web3 provider. So JavaScript VM is basically, like an environment through which you can actually run things on your browser itself. If I just change that with injected Web3, so what I do here is basically there's an instance of Web3 which is called a MetaMask. It is basically my wallet. Through this, I can add funds to my wallet and I can make transactions from it. It is a Chrome extension. So when I choose an injected Web3, there are Chrome extensions. There is an extension called MetaMask that opens up, and I would have to give an access to it. Let's say if I just change it. So if you are doing that to Web3 provider, to run it on Web3 provider, you actually would have to run a blockchain on your local network. Right? You have to create an instance of blockchain. You have to run an Ethereum blockchain on your number, right? And on your local machine, and you can connect from the web from Remix to your blockchain. You can do that by Web3 provider. So what you have to do is basically you have to change the endpoint here, and by specifying which endpoint do you want to connect to, you can do that. So for this, let's start with injected Web3, right? So there's a MetaMask which comes in. I just have to allow it. I have to connect it. It's getting connected, right? And I can see here. So if you see the address, it starts from 0x FE3D and ends with AFDD. It's the same account which is here. 0x FE3 2AFDD. and the same balance 0.98 ether, 0.98 ether. So this wallet is being connected to this account here, right? So what I do here, I just deploy this contract. So when I'm deploying the contract, I do certain actions on the network, and for every transaction that you're doing on Ethereum network, you have to pay a gas. It's like if you want to run your vehicle from a place to another place, you have to fill in with fuel, right? It's the same way how it works. So let's say if you want to visit from your place to a certain place, to let's say you want to move from place A to place B. So to move from place A to place B, you need to have enough fuel to reach up to place B. Similarly, in order to deploy a contract, you need to have enough gas being available in your account. So how is this gas being calculated? So the gas depends on the complex operations that your smart contract has. If it is too much of complex operations, the gas consumed would be high because there are a lot of operations that are being done. So depending on the operations, there are gas fees which are being associated. So let's say I get this. So I'm asked to pay 0.00059 ether as a deployation fees. So you can also see here on the screen. If you just confirm, are you able to see that? Okay, I think you're not able to see that. I'll just stop sharing and I'll share up. Yeah, is my screen great? Okay. So I'll just move to the unit, right? Here is here is the extension that I was talking about. So here you see the gas fee, which is 0.000559. Right? This gas fee is the price in ether that I have to pay. Here you can also see the gas price and the gas limit. So gas price is nothing but it specifies the amount of ether you're willing to pay for each unit of gas. So it's like for per liter, your petrol price is 80 rupees. So you're willing to pay 80 rupees for a liter of petrol. Similarly, for every gas, you're willing to pay 4.76 gigaway. This is a unit. A way is 10 to the power of minus 18 ether. Gigaway is 10 to the power of minus 9 ether. So you're willing to pay 4.76 gigaway as the gas price, and gas limit is the total number of gas, or is the total number of it's the total number of gas that you're willing to expend. So let's say if you want to visit from a place A to B, you know that it is of 18 kilometers, and your vehicle gives you average of 15. So you would need at most one one two you'd need 1.2 liters to travel. However, you would say that okay, I'm willing to spend up to 1.5 liters because there might be places which can have a lot of traffic, and the mileage might decrease or increase during that time, so I'm willing to pay until 1.5 liters for it. So similarly here you have to put in your gas limit about how much is the total gas that you're willing to spend for this transaction. So depending on the gas limit and the gas price, you get a gas fee, and this is the fee that you have to pay. So let's say so if I just increase my gas price, right? So I'm paying the premium to it. So what is the reason to do that? So if I'm paying in premium, miners would be incentivized to take my transaction first. So let's say if you're in a petrol pump queue, and if you're saying I'm willing to pay 100 rupees for 1 liter of petrol, the guys at petrol pump would be willing to put petrol at your vehicle first, right? Just imagine a scenario like that. Similarly, here you're saying for one gas, I'm willing to pay 10.76 gigawatt. So you're paying it a premium. So the advantage to this is your transactions would be done at a faster pace. So let's say we just confirm that. And here you can see that the contract deployment is pending. And if I just move it up here, so the creation of purchase order is pending, but since I've paid a premium, it would be done within like next few seconds. Otherwise, it could have taken until few minutes. So let's wait for the contract to be deployed. Okay. Another thing that we can discuss here now is about the different networks in the MetaMask. So let's say if you're working on the main Ethereum network, you can choose this. Otherwise, there are different test networks. So let's say if I use a Robston test network, you might be wondering about how I got 9.0.98 ethers. So there are a lot of faucets through which you can get in test balance. So let's say I just go to faucet Ethereum Robston, right? And then there are different links. So what I can do, since I've already taken some balance on this account, I'll just create a new account 2, right? I got a new address. I'll go to Robston. I'll ask them to send me test ether. Oh, okay. So basically, they claim that I've also asked for this ether. So as you can see, like the faucet drips 1 ether every 5 seconds. So that is how the faucet gets in ethers, and through faucet you can actually take in ethers for you, and through that ether you can use the transactions. So here we can see that the transaction is completed. The my network or my smart contract has been deployed. Right here also I can check that. So if I just click here, you can see the details. Right, I've created a new contract. This is the total fees that I've paid, and these are the number of amounts. This is the gas price that I've paid for it, and all the other details that are important, right? So here I can actually see in my deployed contracts. So when I just go down, so here we have two things. One is a setter, one is a getter. So here, if I just click on get quantity, what do you think would the quantity return? The constructor has initialized the product quantity to 100, right? So when I'm returning something, when I'm clicking on the get quantity function, it returns me the product quantity variable, which the product quantity variable in this case is 100. So if I just click on get quantity, it returns me 100, right? Let's say now we just set it to a different value. So now the logic here is, if I pass in a value, the product quantity would increase by that value, right? So let's say I pass 10. When I'm setting something, I'm doing a transaction with the network. So when I'm doing a transaction with the network, I need to pay for it, right? So let's say I pay a premium again. So I just confirm it. So my transaction is being sent. I'm waiting for the transaction to be executed. So the process is, once the transaction is sent, miners take these transactions, they validate these transactions, and then they put a series of transactions into one block. So when they add a block into the network, they get a reward for it. And that is when the transaction is successful. So now I'm waiting for the miners to pick my transaction from the transaction pool and to create a block out of it. So this takes like somewhere around up to 10 minutes in an Ethereum blockchain. But since I've paid a premium, I would actually be getting this done in a very short time. So within a minute, this transaction would be successful. So here you can also see there's a Robston Ethereum link. So let's see what that is. So here we can actually see the transaction details. So the status here is pending, which is now converted to success, right? So success means the miners have taken this, they have added into a block. Which block have they added into? The block number is 8807593. The timestamp is 1 minute ago. The from address, if you remember, it's the AFDD, the same address as my MetaMask address. The contract address is this, and the amount of ether and the transaction fee are mentioned here. So now we have updated the list. So we have updated the quantity with 10. So the product quantity would become 110. So let's just get and check how much is are we getting. So we are getting in 110. So let's say if we just change the logic of it, and if we just put that the product quantity should be same as the value, right? So let's just compile that again. It's compiled successfully. Since we have changed a code, we need to compile it again. Now since we have compiled, let's deploy it. So right, this also gives you a sense. So I'm deploying a new contract. So as a developer, if you deploy a contract to the blockchain, that contract cannot be changed. If you want to make changes to it, you would have to deploy it as a new contract, right? So I just deploy this contract. I'm waiting for the contract to be deployed. Meanwhile, I'll just delete the previous deployed contracts. Yeah, so now the contract is being deployed. So let's say if I now update the quantity with 10, that means I'm changing the product quantity value to 10, right? Let me just do that. Okay, before that, let's just get the quantity. What is the quantity that we see currently? It's 100. Why? Because the product quantity is 100. Let's say if I just change it to 110, and if we just get it again, so here you see that we have actually changed the contract, right? Changing of contract would mean you have to you have to deploy the contract again. You're getting it that right? So if I just get it, the quantity is 100. If I just update that, so I pay a premium again for this workshop. You don't have to pay the premium during the live. You can actually use the same. I'm just paying the premium to get the time shortened, right? So the transaction has been pending. This is the Robston link. So we are waiting for the transaction to get successful. Yeah, the transaction is now successful. So if I just get on the quantity becomes 10. Do you get it how this works? So the product quantity is now the value itself. So this is how a basic smart contract, how to write a basic smart contract and how to deploy it and how to, use that smart contract and interact with it. So this is how you can actually create your basic smart contract. In order to read more about it, you can visit the official documentation of the smart contracts. So like it's you can find them. I'll just share the link here with you. Right, so this is the link that you can use to share the details, and this is the link through which, so I think Rakshit, you can actually post this link on the uh, comments. Thank you. Yeah, so this is the link through which you can read about more about the Solidity, how to write smart contracts using Solidity, and how to deploy it. There are a lot more advanced functionalities which are being involved, but due to shortage of time, I won't be able to cover that. So I'm like that sums for this workshop. Also, Rakshit might have informed you about, or the Hack the Mountains team might have informed you about downloading the Zubi app. So basically, once you download the Zubi app from this URL, which is being shown on your screen, so you get 500 Zubi credits. So now the question would be what to do with these credits. You can actually use these credits to take in a lot of courses. These courses can be on blockchain, can be on machine learning, MERN stack, etc. And you can actually start learning about different concepts of blockchain from these credits, right? So let's say if you just come in and refer anyone, you'll get 50 rupees per referral, and the person who is downloading the app from your referral would be getting 600 rupees. Okay, so the best part here is, so since we are partnered with WazirX is India's largest cryptocurrency exchange. So the courses that you do with us, so for every course you get 750 rupees of WazirX tokens. So WazirX is basically a cryptocurrency which you can redeem directly from the WazirX platform, and you can straight away convert that to your bank account, right? So let me just sum that up again. So once you come into the platform, you get 500 rupees as a credit. After completing a course, you get 750 rupees to complete a course successfully. These 750 rupees or $10 are in WazirX tokens, which you can claim and directly get these 750 rupees on your bank account. Isn't this super easy or super cool? Wherein you're taking, let's say, you get the 500 credits to it. So effectively, you're paying 250 rupees. You can even reduce that to 50 by referring to 5 people. So let's say if you refer 5 people, you're getting the course for free of cost. And for completing the course, you're getting 750 rupees or $10 in your bank account. So this is something that you can do. So this is for a limited time offer, and you can actually use the link which has been shared by the team in the comment section to download the mobile application, and through that you can start using it. So if you have any questions, you can join in on our Telegram group. I'll share the link to it, and the team would be happy to help you out on any of your queries. So, and obviously, you have to fill in the feedback form and the attendance form to get your certificates for this workshop. So, uh, Hack the Mountain, maybe you can also use copy the Telegram link. Yeah, great. Thank you. So, guys, that's all from my side. If you have any queries, you can reach out to me on LinkedIn. You can reach out to me on the Zubi's Telegram group. I'd be happy to answer all your questions there. And that's it for today. Keep building, keep developing, and definitely blockchain is something that will create an impact and start learning something around the blockchain. Thank you. You're on mute, Smriti.
I'm so sorry. Thank you so much, Punit, for your valuable time. I hope everyone learned a lot of things from this session and they will take in a lot. And stay tuned for upcoming sessions as well, guys. Hope you all are learning a lot with this. Thank you for joining in.